sum of a geometric series. The sum of a geometric series is given as Sn is equal to a times 1 minus r to the power of n divided by 1 minus r. Now a is the first term, the r is the common ratio, and n is the number of terms you're asked to find the sum of. Now this formula is given to you in your formula book, which could be very useful to you in an exam. However, you could also be asked in an exam to prove that this is the sum of a geometric series. Now this video is going to show you how to find and prove that the sum of a geometric series is what it is shown as being here. Sn is equal to a in brackets 1 minus r to the power of n divided by 1 minus r. Now my suggestion to you is to learn this for your exam is to repeat watching this video a couple of times and try writing it down, watching the video, checking you've got it right. So the first thing to do is to write down how you're going to calculate the sum to n number of terms. So it's going to be sum is equal to the first term, add on the second term, add on the third term, add on the third term, add on the fourth term, etc., all the way until you get to the n minus 2 term, which is the n minus 1 term, plus the nth term of the sequence. Now, what we're going to do is we're going to call this number 1. Now I'm going to multiply what we've just written down all by r again. So we're going to multiply all what we've just wrote down by the common ratio. And if we do that, we get the following. We get Rsn is equal to AR plus AR squared plus AR cubed plus AR to the power of 4 plus, towards the end, the n minus 1 term will now become Rn to the power of minus 1, and the final one would be a times r to the power of n. And we'll call this line number 2. Now what we're going to do is we're going to do the first one minus the second one, and we'll see if we can eliminate any of the parts in our two equations. So the first bit is going to be Sn minus Rsn, so Sn minus Rsm. Now what you should notice is you've got a lot of matching up now between the top and the second row. So AR and AR squared and AR squared, they're going to cancel each other out. AR cubed, and we go to the other end, A times r to the power of n minus 1 appears in both. So the only two bits we're going to be left with now on the right hand side of this equation is our initial value, A, and our final value, which we're going to be taking away, is going to be A times r to the power of n. Now it's take away because remember you're subtracting 2 from 1. Now what we just need to do now is just tidy this up and leave ourselves with Sn on their own. So you should notice here that you can factorise this part here by taking Sn out. So that's going to be 1 minus r, and on the right hand side you should notice that you can take out the common value of a, which is the first term, so that's 1 minus Rn. If you look, we're getting very close now to what we're expecting. We've got a times 1 minus r to the power of n. Now we just need to divide it through by the 1 minus r. So the sum to the n number of terms is going to be a times by 1 minus r to the power of n, all divided by 1 minus r. Now remember, you can be asked to prove this in an exam, so I do suggest you just watch that bit of the video a few times to remind yourself how to get the equation for finding the sum of a geometric series. Let's apply this rule now to a couple of examples. So the first one, we want to find the sum of the first 10 terms of the geometric series 40, 20, 10, 5. Like with all geometric series questions, we want to first identify the first term, which is a, and the common ratio r. So the first term is 40, and what you times 40 by to get to 20? Well, that is the value a half. So in our rule, we're trying to find n, so the sum of the first 10 terms. So sum of the first 10 terms is equal to the first term, 40, multiplied by 1 minus a half to the power of 10, all divided by 1 minus a half. If we do a little bit of tidying up here, you'll get the following. So the sum of the first 10 terms is equal to 40 times by 1 minus 1 over 1024 all over a half. You pick up your calculator and you'll get the value for the sum of the first 10 terms as 79.92. The second question we're asked to solve is this one, where we're told the first term of geometric series is 8 and the common ratio is r. It says write down the second and third terms of the series in terms of r. So the first term, remember, is just going to be a equals 8, and the second term, we take our first term, we times it by the common ratio, but we know that a is 8, so we're actually going to write it as 8r, and the third term is going to be the first term multiplied by the common ratio squared. Well, the first term's 8, so it's r squared. So these two here represent our second and third term. Now, what we're asked to do is just ask now to find out the possible values for r, given that the first three terms add up to 38. So the first three terms, 8 add 8r add 8n squared, are equal to 38. And we're asked to find two possible values for r. Now we've got a quadratic here and we can solve these providing we've got them equal to 0. So we need to bring across, by taking 38 off both sides, we need to bring that 38 across. So we're going to have 8r squared plus 8r minus 30 is equal to 0. Now you can try factorising that, and unfortunately it won't work. We could also try dividing through by the common value 2 to see if we could factorise that, but still this might be quite difficult to factorise, if it factorises at all. So what I'm going to pick is I'm going to pick up the quadratic formula, which we know how to use because we use it a lot in Core 1. So we know that to find the value r, we're going to have minus b plus or minus the square root of b squared minus 4ac all over 2a. And we can easily pick out the values for b, a and c from the quadratic we've got. So the b is going to be minus 4 plus or minus 4 squared, which is 16. 4 times a, well that's 4 times 4, which is 16, times by negative 15 gives 240, and 2 lots of a is going to be 8. So we add the bits in the bracket, in the square root, you get 256, and then divide through by 8. So we're going to have two solutions. We're going to have r is equal to minus 4 plus root 256 divided by 8, and r equals minus 4 minus root 256 over 8. And if you get a calculator, you can find the solutions for both values of r, which are 1.5 and minus 2.5. So remember, the rule for sum of a geometric series to the nth term is given to you in the formula book. However, you could be asked to prove this in your exam.